In this one, we have another word problem for a system of equations. However, unlike the previous one, we're going to have to bounce around a bit when we solve our system. But, like the previous one, we start with the question. How many of each type of cake was made? We don't know how many of each type of cake was made. So that's where our variables kick in. So x will be the number of casata cakes. Y would be the number of carrot cakes. Z would be the number of coffee cakes. And now I'm hungry. Okay. Notice we have each cake to have a mixture of sugar, flour, and vanilla, and then we also know how much total was used. What you have to do is you have to put the like units together, meaning you're going to have an equation of all flour, an equation of, let's go in order, all sugar, all flour, and all vanilla. So don't write an equation that mixes up vanilla and flour and sugar. We don't want that at all. Let's begin. Let's start with the sugar. Each casata cake uses 2 cups of sugar, and we have x casata cakes. 2x represents how many total cups are used of sugar from the casata cake. Each carrot cake needs 3 cups of sugar, and we have y carrot cakes. 3y. Each coffee cake uses 1 cup of sugar, and we have z coffee cakes. 1z. And how much total sugar do we have? We have 23.5 cups. So you don't have to write the units because it's cups equals cups, and that's all we need. Next up, flour. Each casata cake needs 4 cups of flour. We have x casata cakes plus, actually, I want you to pause the video and I want you to see if you can get the rest of it. I'm assuming that you paused it. I can't really tell. I'm not standing behind you or anything. Alright. So 4 cups of flour in each casata cake. We have x casata cakes plus carrot needs 2 cups of flour, and we have y of those. Coffee needs 2 cups of flour, and we have z of those. And we have a total of 27 cups of flour. Vanilla, 1 tablespoon in casata, 3 tablespoons in carrot, and also another 3 tablespoons in coffee. Total of 30.5 tablespoons. Alright. So now we're back in the previous section. We're going to solve for the variable by elimination. I would choose either x or z to eliminate because the coefficients of y are not 1 nor -1. So I'm going to choose x. I'm going to pick the first 2 equations, multiply the first one by -2. And keeping the second equation just the same. Notice upon doing so, by eliminating x, notice z also eliminates, and we get -4y equals 20, which means y equals, -20, which means y equals 5. Which is awesome. That means one of the variables is already solved for. However, we can't skip to step 5 and back substitute, because if we tried to put 5 in for the y, we still have an x and a z to contend with. So we have to go to step 2, which says eliminate x again. So I'm going to pick the last 2 equations this time. I'm going to keep the second equation the same. And what am I going to have to multiply the last one by to get rid of x? Hopefully you said -4. Doing so, I get -4x minus 12y minus 12z equals, I think that's -122. Adding them together, the x's are gone. I get -10y minus 10z equals -95. So step 3 would say eliminate another variable, and step 4 would say solve for the remaining variable. Well, notice that we already have that done. So we can go right into step 5. So instead of that y, I can now put in 5. So this is -50 minus 10z equals -95. Adding 50 to both sides. And dividing by -10, I get z to be 4.5. Now I know it might seem weird to have a decimal cake, but you might see in stores that they make half a cake sometimes. It happens, I promise. If not, you should probably visit a store. Okay, so now let's go to the original equations and try to find x. I'm going to use the third one because the coefficient of x is already 1. It's a little bit easier. So I'm going to put in 5 in for y. I'm going to put in 4.5 in for z. So this is 15. This is 13.5. So combined, that is 28.5. So subtracting that from both sides, I get x to be 2. So they should make, or they did make, I should say, 2 casata cakes, 5 carrot cakes, and 4.5 coffee cakes.